Hello and welcome. Sometimes the biggest changes happen so quietly you don't even notice them. Today, we're talking about a secret revolution happening inside Tesla. It's a move that started as a clever way to save some money on copper, but it has triggered a massive, unforeseen consequence that could shake the entire global metals market.
For years, all the experts, all the analysts on Wall Street, they've been telling us to watch certain metals for the electric car boom. But what if they've all been looking in the completely wrong direction? What if the real story, the most important one, has been hiding in plain sight this whole time?
Right? So let's get into it. Everyone, and I mean everyone, was obsessed with lithium for the batteries, and of course copper for all the wiring. But while the world was focused on those, Tesla was quietly playing a completely different game. They were solving a fundamental engineering problem, one that forced them to look beyond these usual suspects for a much more precious solution.
Now, the logical bet was pretty simple. More electric cars means a whole lot more wiring, which means you're going to need a mountain of copper. It makes perfect sense, right? Well, that simple math missed a brilliant innovation that was brewing deep inside Tesla's engineering labs.
Think about this for a second. The electrical system in cars hadn't really changed since the 1950s. But today's cars aren't just engines and wheels, they're computers. They've got huge touchscreens, radar, cameras, dozens of sensors. The old 12-volt system was like trying to water your entire lawn with a tiny spray bottle. It just couldn't handle the load anymore.
So here's where Tesla made a really radical move. They decided to quadruple the car's electrical pressure, the voltage, taking it from 12 volts all the way up to 48. Now, this wasn't just a minor upgrade. No, this was a complete redesign of the car's entire nervous system, and it unlocked some incredible new efficiencies.
And this table really shows you the genius behind the idea. See, by quadrupling the voltage, you get to cut the electrical current by 4 times. And less current means you can use much, much thinner wires. In the end, Tesla cut the weight of its copper wiring by a whopping 70%. That saves a ton of money and even makes the car's range a little better. But there was a catch.
As any engineer will tell you, there's really no such thing as a free lunch in physics. This new high-voltage system was incredibly efficient, but it also created a very dangerous new problem, one that could lead to total failure if it wasn't solved with exactly the right material. At 12 volts, electricity is pretty tame, but when you get up to 48 volts, it starts to get a little feisty. It can actually jump across a tiny gap of air when you flip a switch. This creates what's called an electrical arc, an intensely hot little spark of plasma. You can think of it as a miniature lightning bolt going off inside every single switch in the car.
And that little lightning bolt is a huge, huge problem. If the contact points in your switch are made of something normal, like copper or brass, that constant sparking will melt and destroy them. The switch will either weld itself shut or it'll just fail completely. Can you imagine your power steering failing because one tiny contact melted? It's just not an option.
So, Tesla, who is betting their entire company on safety and reliability, had to find a material for all these tiny connectors and relays that could withstand that intense heat thousands and thousands of times for the entire life of the car. So what on earth could they use?
Well, the answer is simple. It's elegant, and it turns out it's incredibly important. The one metal on the entire periodic table that could do the job is silver.
So why silver? For a company that's famous for pinching every penny, why choose a precious metal? What makes silver the one non-negotiable secret ingredient in this new 48-volt system?
Well, silver basically has 2 superpowers. First, it has the highest thermal conductivity of any metal, which means it gets rid of the heat from that spark almost instantly. And second, even when it tarnishes or oxidizes, that tarnish still conducts electricity perfectly. It just doesn't fail. It is the only metal that could guarantee the safety and reliability they needed.
It's really an elegant solution to a very dangerous problem. And, before we get into the massive market implications of this, we just wanted to take a moment to say, if you're enjoying this explainer, a quick click on the like or subscribe button really helps us make more of them for you.
Okay, so if this was just about a few million Teslas, it might not be that big of a story. But here's the thing. Tesla doesn't just build cars. They set the new standard for the entire industry. And now, Ford, General Motors, Toyota, they're all racing to switch to this 48-volt system. We're talking about 90 million new cars built every year, and that's where the math really gets explosive.
Just look at this jump. Your regular old gas car has about 15 to 20 grams of silver in it. A standard EV already uses about double that, but this new 48-volt system, it nearly doubles the amount again,
all the way up to 60 grams of silver. That's almost 2 ounces in every single car.
So let's run some numbers, and we'll even be conservative. Let's say just half of the world's new cars adopt this new system in the next few years. While that alone creates a brand new demand for almost 30 million ounces of silver every single year. This is new demand that simply did not exist before.
And just to put that number into perspective for you, this one single change in car technology will soon require an amount of silver that's almost equal to the entire yearly mining output of the United States. A new tidal wave of demand is building right before our eyes. So you might be thinking, why don't the miners just dig up more silver? Well, here's the real kicker. Most of the world's silver doesn't actually come from silver mines. Over 70% of it is just a byproduct. It's the little bit of extra stuff they find while they're mining for things like zinc, lead, and copper. What this means is that the supply is inelastic, as the economists say. You can't just ramp it up when the price goes up because its supply depends on the demand for other metals. And on top of that, we're finding less silver in the rock we mine, and the world's biggest supplier, Mexico, is making it harder to get out of the ground. Now think about it from the car maker's point of view. For a $50,000 car, what's the difference between $100 worth of silver and, say, $1,000 worth? It's practically nothing. They have to have the silver to prevent fires and ensure the car works. They are not sensitive to the price. They'll simply pay whatever it costs to keep those assembly lines running.
So let's just put all the pieces together here. You have a massive industry, the entire global car market, that is not sensitive to price. They have created a huge, permanent new demand for a critical metal. And the supply of that metal is fixed, it's getting harder to find, and it's facing political risks. You couldn't write a more perfect storm.
The plans have already been drawn up. The factories are already changing their tools. The entire auto industry has committed itself to a future that requires a metal that the world might not be able to provide, at least not at the scale they're going to need it.
You see, this isn't just a temporary fad. It's a permanent change in technology, a change that is locked in by the laws of physics and the need for safety. And that leaves us all with one final and very important question to think about as this quiet revolution unfolds.